Find the x and y-intercepts of the graph of the given equation. The equation is 2x minus 7y equals 6. Let's start by finding the x-intercept. You can find an x-intercept by letting y equal 0. That's because an x-intercept is where the graph crosses or touches the x-axis. So if we have our graph, the x-intercept is the point where it crosses or touches the x-axis. And any point that is on the x-axis will have an ordered pair with the y-coordinate being 0. So if we let the y-coordinate be 0 in this equation, we're going to find whatever that x-coordinate is of the x-intercept. So in the equation, we let y equal 0. That gives 2x minus 7 times 0 equals 6. 7 times 0 is 0, so we have 2x minus 0 equals 6. 2x minus 0 is 2x. And then we'll divide both sides by 2 to get x equals 3. So that means that we'll have an x-intercept at 3, and sometimes we're asked to write that as ordered pairs. So we would have the ordered pair 3, 0. So then we want to find the y-intercept. To find the y-intercept, we'll let x equals 0. Now we do that because a y-intercept is where the graph crosses or touches the y-axis. And any point on the y-axis is going to have an x-coordinate of 0. So in our equation, if we let x equal 0, we're going to be able to figure out what that y-coordinate is. So in our equation, substituting a 0 for x would give us 2 times 0 minus 7y equals 6. 2 times 0 is 0, leaving us with 0 minus 7y. 0 minus 7y is negative 7y. Equals 6, and we'll solve for y by dividing both sides by negative 7, and that gives y equals negative 6 over 7. If we were to write that as an ordered pair, it would be 0, negative 6 over 7. So we found the x and y intercepts for the equation 2x minus 7y equals 6 to be 3, 0 for the x-intercept, and 0, negative 6 over 7 for the y-intercept. Graph the equation 5x minus 4y equals x by plotting points. And on this example, we are given the x values that we're going to use. So in this, we'll start with the first x value. X equals negative 8, and we'll substitute it into our equation. That gives 5 times negative 8 minus 4y equals 8. 5 times negative 8 is negative 40 minus 4y equals 8. I'll add 40 to both sides to get negative 4y equals 48, and I'll divide both sides by negative 4. That gives y equals negative 12. And so we have our y-coordinate being negative 12, and the ordered pair is negative 8, negative 12. We'll do the same thing with the next x value, which is x equals negative 4. 5 times negative 4 minus 4y equals 8. 5 times negative 4 is negative 20. Minus 4y equals 8. We'll add 20 to both sides. Negative 4y equals 28. And if I divide both sides, I'll have, by negative 4, I'll have y equals negative 7. So we have a y-coordinate of -7 and an ordered pair of -4, -7. I'm going to zoom out just a little bit so I have some more space. And we'll use an x value of 0. It gives 5 times 0 minus 4y equals 8. 5 times 0 is 0. 0 minus 4y is -4y. We'll divide both sides by -4, and y equals -2. So for x equals 0, we have y equals -2, and the ordered pair is 0, -2. We have one more x value. That's x equals 4. And that would give 5 times 4 minus 4y equals 8. 5 times 4 is 20. So we have 20 minus 4y equals 8. I want to isolate the y by subtracting 20 on both sides. That gives -4y equals -12. I'll divide both sides by -4, and y equals +3. So for an x value of 4, we have a y of 3, and the ordered pair for 3. I'm going to zoom back in on my graph so we can see where to plot these ordered pairs. We have -8, -12 would be here. -4, -7 would be here. And 0, -2, and 4, 3. You can see that these points are lining up in a straight line, which is what we expect because this is a linear equation. And we can connect those points with a straight line. To graph our equation. So now we have a sketch of our equation, 5x minus 4y equals 8, and we've graphed that by plotting points. Decide whether f is even, odd, or neither. F is equal to x to the 4th minus 2x squared plus 6. So we want to decide whether f is an even function, an odd function, or neither. And we have some definitions for a function being even. Function is even whenever it follows this definition. F of -x is equal to f of x. And essentially, this is a symbolic way of saying that the function has y-axis symmetry. And then a definition of an odd function will follow the pattern of f of -x equals -f of x. And this is a symbolic way of saying that the function has origin symmetry. And then if our function doesn't fit into the categories of even or odd, then we can say that they are neither even nor odd. So I've developed a process that we can go through to determine whether a function is even or odd algebraically. So what we're going to do is we're going to calculate f of -x. And the reason why we calculate that is that you can see in the definition of even, f of -x, and in the definition of odd, f of -x. So we're going to do that calculation of f of -x, and then we're going to check it versus these two definitions. So if we end up with the calculation of f of -x coming out to be f of x, which is the same as the original function, then we know that the function is even because it's following that definition of even. And if our calculation of f of negative x comes out to be the opposite of f of x, or negative f of x, that means it's following the definition of being odd, and we can say that it's an odd function. However, if when we do the calculation it doesn't fit into either of those categories, if it's not f of x or negative f of x, then we are going to put it into the category of neither even or odd. So we're going to calculate f of negative x, and that means that we're going to substitute a negative x in for every x. That would give negative x to the fourth minus 2 times negative x squared plus 6. And if we work this out, negative x to the fourth is negative x times negative x times negative x times negative x. You really don't have to write this out if you don't want to. What we notice is that we have an even number of negatives, and an even number of negatives when multiplied will be a positive. So we'll just focus on the x's. X times x times x times x is x to the fourth. And we'll do the same thing with negative x squared. This is minus 2. Negative x squared is negative x times negative x. Once again, we have an even number of negatives. So we end up with, well, we get this extra negative here, so it's a negative. So it's really an odd number of negatives with that extra negative there. So that's 2x squared plus 6. So we've done that calculation of f of negative x. And once we look at that calculation, you can see that it is the same as the original function. And so that means that f of negative x is equal to f of x, and that fits the definition of even. So we know that the function f of x equals x to the fourth minus 2x squared plus 6 is even. Find the equation of the line passing through the points negative 6, 5 and 4, negative 7. Write the equation in point-slope form, slope-intercept form, and standard form. So we're given 2 points that are on a line, and we have a formula for the slope of that line, which is y2 minus y1 over x2 minus x1. So this will give us the slope. We just need to choose one of the points to be x1, y1, and choose one of the points to be x2, y2. And it doesn't matter which one is which. And then you'll substitute into the slope formula. So the y2 is negative 7, y1 is 5 over x2 minus x2 is 4 minus x1 is negative 6. So in the numerator that gives negative 7 minus 5, which is negative 12. And in the denominator we have 4 minus a negative 6. 4 minus a negative is plus. So 4 plus 6. And 4 plus 6 is 10. Then we'll reduce this fraction. They have a common factor of 2, so that becomes negative 6 over 5 when we cancel out the 2's. So we've got the slope now. Now the reason why we needed the slope is because we are going to use the point-slope form of the equation of a line. The point-slope form is y minus y1 equals m times x minus x1. So the point slope form allows us to get the equation of the line if we have a point, which we were given a point. However, we did not have the slope of the line, so we needed to calculate the slope so that we could substitute into this formula. So let me substitute those two values in, and that gives y minus 5 equals negative 6/5 times x minus negative 6. I'm going to simplify this double negative here, and I have y minus 5 equals negative 6/5 times x plus 6. So we use the point slope form, and we've substituted in a point on the line and the slope of the line, and now we have the point slope form of the line, which is the first form that we want to write the equation in. Then we want to write the equation in slope-intercept form. Slope-intercept form is y equals mx plus b. The m stands for the slope, the b stands for the y-intercept, and that's where it gets its name, slope-intercept form. So we want to take our equation that we created in point slope form and manipulate it into slope-intercept form. So that's going to require us to get rid of all the parentheses and also to isolate the y on one side of the equation. So in this example, we have a slope that is fractional. So this can be a little bit messy. So I'm going to use a technique that allows us to avoid adding fractions and having to get a common denominator. So I'm starting with that equation, y minus 5 equals negative 6/5 times x plus 6. And the first thing that I want to do is to get rid of the fraction. And you're going to get rid of the fraction by multiplying the right-hand side by the denominator. We could just, instead of 5/1, we could just do 5. And then I also need to balance by multiplying 5 onto the left-hand side. So this gives 5y minus 25 when I distribute. And on the right-hand side, the 5's will cancel, and we no longer have a fraction. And then we can use the distributive property to get rid of the parentheses. So that's negative 6x minus 36. So now that we've gotten rid of the fraction, I'm going to isolate the y by adding 25 to both sides. That gives 5y equals negative 6x. Now add negative 36 plus 25. And let's see, 25. Okay, I can go ahead and do that and get a negative 11. And then I want to get y by itself, and I'll divide by 5, and that gives y equals negative 6/5 x minus 11/5. So we've now written this equation in slope-intercept form. Where the slope is negative 6/5 and the y-intercept is negative 11/5. Now, if you are comfortable with fractions and you don't feel the need to get rid of the fractions like we did here, I can show you how to do how to get that slope-intercept form. Let's rewrite this. We have y minus 5 equals negative 6/5 times x plus 6. And you're going to use the distributive property to get rid of the parentheses. And that would give y minus 5 equals negative 6/5x and negative 36/5. So we've gotten rid of the parentheses. Now we'll isolate the y. I'll add 5 to both sides. And that gives negative 6/5 x. And in order to add the negative 36/5 plus 5, we have to have a common denominator. So we'll write 5 as 5/1. I want to get a common denominator of 5. So I'll multiply by 5/5. And that changes 5 to be 25/5. So now we'll add negative 36/5 plus 25/5 because they have a common denominator, and that becomes negative 11/5. So you can see that we get the same slope-intercept form of y equals negative 6/5 x minus 11/5. So we have one more form to write out, and the last form is called standard form. And standard form is when you have ax plus by equals c. So what that means is that you have your x term and your y term on the same side of the equation, and then the constant on the other side of the equation. So we want to manipulate our equation to put it in this form. Now, sort of an unwritten rule is that we don't want our coefficients to be fractions or decimals. So we have to take an extra step and not only put our x and y term on the same side, but we need to clear the fractions that we have. So let's start off with our slope-intercept form that we had. Y equals negative 6/5 x minus 11/5. If I want the x and y terms on the same side, I'll add 6/5 x on both sides, and that gives 6/5 x plus y equals a negative 11/5. And so we do have this format of having x and y on the same side and the constant on the other side, but we need to clear those fractions. And you're going to clear the fractions by multiplying by 5 on the left and multiplying by 5 on the right. When you multiply by 5 on the left, you do need to use the distributive property. When you multiply it times the first term, the 5's cancel out and you're left with 6x. And when you distribute to the second term, you get 5y. And on the constant term on the right-hand side, the 5's cancel out and you're left with negative 11. So the standard form is 6x plus 5y equals negative 11. And I forgot to mention one more unwritten rule, and that is that they don't want a negative in the leading coefficient. No negatives on A. And we didn't have to deal with that in this example, but if you did have a negative, you would just multiply every term by a -1 to change the signs. So we have our equation written in slope-intercept form, standard form, and also point-slope form. Find the center, radius, and intercepts of the circle with the given equation and then sketch the graph. Our equation is x squared plus y squared plus 2x minus 10y plus 1 equals 0. So this is the equation of a circle, and this equation is written in the general form. We've got the general form of a circle, and in order for us to find the center and the radius, we need to convert this general form into standard form. And standard form is when you have x minus h squared plus y minus k squared equals r squared. And what we're going to do is we're going to use completing the square in order to do that conversion from general form to standard form. So with completing the square, you want to group your x terms together and group your y terms together. So that would give us x squared plus 2x grouped together. And we'll group the y squared minus 10y together. And this this plus 1, we're going to subtract 1 on both sides to move that constant to the other side. So we've done the grouping, and now we'll use the completing the square process. And with the completing the square process, you take the coefficient on your x term, so I'm going to take 2. You divide that by 2 and square it. 2 divided by 2 is 1, 1 squared is 1, and we consider 1 to be sort of like our magic number. And what it's going to do is it will, if we add it to our x group, it will make that x group factor into a perfect square. So we're going to add that 1 to the x group, but we have to balance the equation. So whatever we do to one side of the equation, we have to do the same thing to the other side. So we're also going to add 1 to the other side. Now we're going to do this again with the y group. So we start with the coefficient on the y term, negative 10. We're going to divide that by 2 and square it. Negative 2 over 2 is negative 5, and negative 5 squared is 25. So that gives us our magic number for the y group, and that's going to cause the y group to factor into a perfect square. So in the y group, we're going to add 25. To balance the equation, we'll also add 25 to the right-hand side of the equation. So now when we look at the x group, we're going to try to factor it. And we factor it, we get x and x, 1 and 1 with both pluses. And you can see that we have x plus 1 times x plus 1, which is the same thing as x plus 1 squared. That's our perfect square. The same thing will happen to the y group. When we factor the y group, y squared minus 10y plus 25, we're going to get y times y is y squared. 5 times 5 is 25, and we need minuses there. And we have y minus 5 times y minus 5, which is y minus 5 squared. So that y group factored to a perfect square. And then with our constants, negative 1 plus 25 is 25. So we were able to start with the general form, and using completing the square, we've now turned this into the standard form. And now that it's in the standard form, we can recognize the center and the radius. The center is the ordered pair HK, and we have on the right-hand side the radius squared, so we can identify the radius. So the center of this circle is negative 1, 5, with a radius of 5. We have a little bit more to do. We want to find the intercepts of the circle and also sketch a graph of the circle. So we'll find the intercepts, and I'll use the standard form to find the intercepts because it's a little bit easier. So to find an x-intercept, I'll let y equal 0. So using my standard form, x plus 1 squared plus y minus 5 squared equals 25. I'll substitute a 0 in for that y, and that gives x plus 1 squared plus 0 minus 5 squared equals 20. Excuse me, I copied that wrong. That should be 25, not 20. And if we continue, we'll have x plus 1 squared. 0 minus 5 is negative 5. Negative 5 squared is 25. I want to isolate this square term, and I do that by subtracting 25 on both sides. And that gives x squared plus 1, that's x plus 1 squared. X plus 1 squared equals 0. Let's get rid of the square by square rooting both sides. That's x plus 1 equals 0, and I subtract 1, and x equals negative 1. So we do have an x-intercept. And that x-intercept is negative 1, 0. Now I'll find the y-intercept. I'll find the y-intercept by letting x equal 0. So substituting a 0 in for this x position would give 0 plus 1 squared plus y minus 5 squared equals 25. 0 plus 1 is 1. And 1 squared is 1. And once again, I want to isolate this square term. I'll do that by subtracting 1 on both sides, leaving me with y minus 5 squared equals 24. I'm going to get rid of that square by square rooting both sides. And that leaves me with y minus 5 equals plus and minus square root of 24. And I'll try to simplify that radical. We can write 24 as 4 times 6. And the square root of 4 is 2. We'll leave the 6 inside. And I'll isolate y by adding 5 to both sides. So we have y equals 5 plus or minus 2 square root of 6. And that gives us our two y-intercepts. The y-intercepts will be 5 plus 2 square root of 6 and 5 minus 2 square root of 6. So we have one final thing to do, which is to sketch a graph of the circle. And to sketch a graph of the circle, we only need the center and the radius. So the center is negative 1, 5 with a radius of 5. Our center is negative 1, 5 with a radius of 5. Negative 1, 5 would be here. That's our center. From the center, we're going to use the definition of the radius. So the radius is the distance from the center to the points on the circle. So if we go a distance of 5 units up, we get here. That point will be on the circle. A distance of 5 units right, that point will be on the circle. A distance of 5 units down, this point will be on the circle. And a distance 5 units left, this point will be on the circle. So now these 4 points are on the circle, and we can sketch the rest of the circle from there. So we have that sketch of the graph of a circle. For this question, we're given a graph, And we want to use that graph to determine the domain and range of the function. So before we start finding the domain and range, this particular graph may have some features that you're not familiar with. So I want to explain, as we look at this picture, how we need to look at what's happening at these arrows combined with these dashed lines. So typically when we have an arrow on the end of the line, we are supposed to assume that the pattern that we see continues. And so the pattern that we see established by this line is that it's going up and to the right and up and to the right. Now it will continue to go up and to the right. However, when we combine that with this dashed line here, what that means is that it will go up and to the right, and it will only go as far as this line here, this dashed line. So this dashed line is occurring at -2. So although this line goes up and to the right and up and to the right, it will never pass that x equals -2. So you can see that this is occurring in a few different places on the graph. If we look down here at this part right here, we have this line, it's going down and to the left and down and to the left. Combined with this dashed line here means that the line will continue to go down and to the left, but it will never cross that -2 value. It can happen right here as well. You can see this arrow means the graph goes down and to the right and down and to the right, but combined with this dashed line, it will never cross a value of 2. And it also occurs right here. This arrow is going up and to the left, and then combined with this line, you can see this is at 2. The line will never cross that value of 2. So hopefully that helps you a little bit. That will help us find the domain, but we need to look at these arrows on the ends as well. These arrows are also indicating that the pattern continues, and this arrow is going down and to the left and down and to the left. And what we see here is another dashed line. This dashed line is going to indicate that 4 will not be crossed by this line. So it will continue to get closer and closer and closer and closer to 4, but it will never cross over 4 or even reach 4. And the same thing is happening on the right-hand side over here. This arrow indicates the pattern is going down and to the right, but because of the dashed line, it will never cross that value of 4. These dashed lines that we see drawn on the graph are called asymptotes. And the vertical ones are called vertical asymptotes, and we have one horizontal line, and that is a horizontal asymptote. And so these asymptotes are indicating that the line is getting closer to those values without reaching those values. So that information is hopefully helpful to understanding how we get the domain and range of this function. So when I'm looking for the domain and range, first of all, you need to know that the domain are the first coordinates or the x's, the range is the second coordinate or the y's. And I'm going to use a ruler to help guide this discussion of the domain. And I'm going to hold the ruler vertically. And the reason why I hold it vertically is because that ruler is pointing to the x scale. So when I hold the ruler, it's going to help me to understand where my domain starts, because that will be the first x value. So if we look at this, Our line looks like it starts at -10, but we have to keep in mind that the arrow means that the pattern continues. It will continue to go down and to the left and to the left, and so that means -10 is not really our first x value. That arrow continues on forever, and our first x value will be -infinity. So the domain is going to start at -infinity. We continued to move our ruler from left to right. We always go from left to right, which is smallest to largest. And that's because interval notation is always written smallest to largest. So if we continue moving our ruler to the left, what I'm paying attention to is that the graph is existing for these x values. So as long as my ruler is touching the graph, I know the domain continues. So the domain continues on, and then we get to this arrow. So that's where knowing what this arrow means along with this line is helpful. The arrow means that the pattern continues going up and to the right, up and to the right. However, that line is a stopping point. The arrow will never reach the line, and so that means that -2 is not part of the domain. So we are going to stop our domain at -2. Then when we move past that vertical line, we can see down here on the graph that the ruler is touching, which means those x values are part of the domain. So our domain starts again at -2 and continues all the way till we get to that next vertical line. That next vertical line occurs at 2. So our domain is going till 2. So remember, we know this because we've learned what the combination of that arrow and the dashed line mean. We will continue to go over and to the right until that line. We never reach that line, which is at 2. So 2 cannot be part of the domain. And then on the other side, the same thing with this arrow. The graph starts again, the domain starts again right after that value of 2. And it continues on. This arrow indicates it's going on forever to infinity. So what we have here is our domain going from -infinity to -2, union with -2 to 2, union with 2 to infinity. Said in a slightly different way, we're saying that the domain is all real numbers except -2 and 2. So where we see those vertical dashed lines at -2 and 2, these are the only values that don't exist on the graph, that don't exist on that line. So we want to do the same thing when we're looking for the range, except we're now going to hold our ruler horizontally. Let me erase some of these markings so they're not as confusing. And I'm holding that ruler horizontally because we're now looking for the range, and the range consists of the y values. So we are now looking at the y scale. And as we look right here, this looks like the first time the graph is starting. However, we've got those arrows. Those arrows mean that the pattern continues. It continues to go down forever. And so that means that our range is going to start at -infinity. And as we look at this, these y values are part of the graph. So the range is going to continue The range continues until the line ends, and the line ends right here. Excuse me, right here is where the line ends. And so that y value where the line ends is 0. And I'm going to put a bracket on that 0 because that point, that's the ordered pair 0, 0. And that point is on the graph. So 0 should be included in the range. So we're going to continue and notice that along this section of the graph, I'm going to highlight it here. Along this section of the graph, you don't see that red line. You don't see a line there, and there are no y values on that section. So we skip that section, and we get up to here. And recall what these arrows mean here. That means that the line is going to follow the pattern leading up to the dashed line. It will never reach that dashed line, but it will lead up to it. So that means that our range is going to start again at 4. And if we go above that line, we have y values all the way up. And then, of course, we know what these arrows mean. It goes up forever, so that means our range goes to infinity. So this graph is showing a range of -infinity to 0, including 0, union with 4 to infinity. So we found the domain and range of this particular graph. Find the intercepts in the y-intercept of the function. F of x equals 3x squared minus 4x minus 3. I'm going to start with the y-intercept because the y-intercept is usually a little bit easier to find. When you're looking for a y-intercept, you're going to let x equal 0. We're using function notation, so that means substituting a 0 into the function. That will give 3 times 0 squared minus 4 times 0 minus 3. 0 squared is 0, 3 times 0 is 0, 4 times 0 is 0, and this simplifies to be -3. So we get a y-intercept of 0, -3. Now let's take a look at the x-intercept. To find an x-intercept, you let y equal 0. Now we're using function notation, so initially you don't see a y in the equation, but you have to keep in mind that f of x is the same thing as y. So f of x is the y, and we're going to set f of x equals 0. That will give 0 equals 3x squared minus 4x minus 3. And we want to solve this quadratic equation. Now, initially, I always try to solve quadratic equations by factoring. But if we take a look at this one, the possible factors are, for the first term, we want to multiply to be 3x squared. That would be 3x and x. And for the last term, the possible factors of 3 would be 3 and 1. So this is one possible factorization. But we need to make sure that it has the right middle term. And so when we multiply the inside, we get 3x, and the outside, we get 3x, and 3x cannot combine together with adding or subtracting to get 4x. So we know this is not right. So then we might try to switch this up a little bit. Put the 1 here and the 3 here. But now when we do that multiplication of the inside and the outside, we get x and 9x. And I can see clearly that if I add x and 9x, I get 10x. If I subtract x and 9x, I get 8x, and neither one of those gives us the right middle term. And I've also exhausted all of the possible factors. So that means that this quadratic equation cannot be solved using factoring. So that means I need to rely on one of my other methods for solving quadratic equations. And the two that work all the time are completing the square and the quadratic formula. So using completing the square can be a little bit involved. It has a lot of steps and can be kind of messy when you have to deal with fractions, and you would have to deal with fractions in this example. So I'm not going to use completing the square. I'm going to use the quadratic formula. And the quadratic formula is a formula for solving quadratic equations using the coefficients of the terms in that quadratic equation. So the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the a, b, and c that you see in the formula, if we have our quadratic equation, it's going to be ax squared plus bx plus c. The a is always attached to the square term, the coefficient of the square term. The b is always the coefficient of the x term, and the c is always the constant. So in our example, a is 3, b is negative 4, and c is negative 3. So we're going to substitute those values into the quadratic formula. And that will give us negative 4 plus or minus the square root of negative 4 squared minus 4 times 3 times negative 3. This is all over 2 times 3. So negative times negative 4 is positive 4. Negative 4 squared is 16. So what I'm doing at this point is I'm simplifying the expression using order of operations. And negative 4 squared is 16, and 3 times 3 is 9, times 4 is 36, and we have a plus 36 because we have an even number of negatives. 2 times 3 is 6. We have 4 plus or minus, and we're going to combine the values underneath the radical. That would be a 52. 16 plus 36 is 52. And I'll simplify the radical. Underneath the radical we have 52, and 52 is the same thing as 4 times 13. And the square root of 4 is 2. The 13 stays underneath the radical. And the final thing that we do when simplifying this, remember this is a fraction, and we always want to write fractions in lowest terms. And you're going to look for what they have in common. So if we look at these three values here, they all are even, so we're going to be able to cancel out a 2 from each one of them. And 2 goes into 4 2 times, 2 goes into 2 1 time, we don't need to write that one, and 2 goes into 6 3 times. So this is one way we can write the answer. Some people like to write this as 2 separate fractions. If you write it as 2 separate fractions, you would write 2/3 plus or minus square root of 13 over 3. And those would be our x-intercepts. If you write them as ordered pairs, that would be 2 plus or minus square root of 13 over 3, comma 0. Thank you for checking out my videos. Have a great day.